Alrighty, in this video, we are going to be talking about the product and quotient rules, and then we'll talk a little bit about higher order derivatives. The product rule, this one's easy peasy lemon squeezy. So let's say that you are given two functions. Let's say that you're given f of x and g of x, and they're being multiplied together. Let's call this h of x. And let's say that we wanted to take the derivative of this. So the derivative of this is just going to be the first function times the derivative of the second function plus the second function times the derivative of the first function. So first times the derivative of the second plus second times the derivative of the first. And that's what we're going to do for the product rule. So for example, here on number one, I have a product, I have a square root of x, and I have 4 minus x squared. I have f of x. We're going to pretend that's f of x, and we're going to pretend that this is g of x. So my first function and my second function. So I'm going to do first times the derivative of 4 minus x squared, which is just negative 2x, plus second, so my second function, times the derivative of my first function, which is 1 over 2 square root of x. And that's, that's it. Now, I did give you a little side note that it's easier for us to do the power rule if I were to multiply this out. If I were to do the power rule, we're going to have 4x to the 1/2 minus x squared times x to the 1/2, which is x to the 3/2. Just kidding. 2, so 5/2. 5/2. And then if I were to take the derivative of this, I'm going to get 2x to the negative 1/2 minus 5/2 x to the 3/2. And this right here, believe it or not, is actually equivalent to this in red. So later down the line, whenever you guys are taking your little assessments and whatnot, it's going to be good for us to know what's going to be more efficient in terms of taking derivatives. Now, number 3, we can't really do what we did in number 1 where we just multiply it out because we have ln of x and 6x plus 5. So we're just going to go ahead and use a power rule where we have first times the derivative of the second, which is just 6, plus second, so 6x plus 5, times the derivative of the first, which is just 1 over x. So this right here would be our answer for number 3. All right, the quotient rule. So let's say that instead of us multiplying two functions together, let's say that we are dividing two functions. So let's say that we have f of x and g of x. Well, to take the derivative of this, we are going to do low d high minus high. Let me move this. Minus high d low all over low square. And this right here would be my derivative for two functions with a quotient. Likewise, for number 2, I'm going to show you how to do this using the quotient rule. And then, of course, our little hint says, hey, it's easier for us to use the power rule to divide this out first. So quotient, I'm going to have low, so my bottom function, times the derivative of the high, so my top function, minus high times the derivative of the low all over low square. Remember that on the AP exam, you don't need to simplify, so if you want to keep it pretty and nasty like this, by all means, keep it nasty like this. Now, on an MCQ, you might get the simplified version because obviously this one you could just use the power rule, because here, this can be rewritten as, let's say, 3/7 x to the negative 1 minus 2/7 x. And then if I want to take the derivative of this is just going to be negative 3/7 x to the negative 2 minus 2/7. And how See how this right here is definitely prettier than this mess right here. So obviously, again, whenever we are thinking about what's the most efficient way, let's think, hey, we could use a power rule. Number 4, we have 3 minus 2x squared over 7x plus 1. This one, we can't really divide this, so we're just going to go ahead and use the quotient rule where I have my bottom, so low, times the derivative of the high, minus high, times the derivative of the low, all over low square. All right. We are gonna do 5 through 8 in class together. I think this is really fun. Finding the derivatives of the trig functions, using quotient rule. Lots of fun. Here, as a little preview, what we're gonna do with 5, 6, 7, and 8 is basically turn our trig functions into sines and cosines, and then use quotient rule and call it a day to find these derivatives. And then once we're done, I do expect you guys to memorize these derivatives whenever you guys take your assessments. But I do want to go down to number 13 and 14 here. Back in our basic derivatives video, we talked about how the derivative of cosine was negative sine. And the derivative of that is going to be negative cosine. And the derivative of that is going to be sine. And then you'll probably notice something after that. My fourth derivative becomes cosine, and it just repeats itself. So thinking about that, if I want to find the 82nd derivative, I'm just gonna find the closest multiple of 4 that doesn't go over 82 and then count from there. Well, if I do that, this is gonna be number 80. This is gonna be the 81st derivative, and this is gonna be the 82nd derivative. So the 82nd derivative of cosine is going to be negative sine. Crazy. Likewise, for number 14, if I want to find the fourth derivative, I'm just going to take the derivative 4 times and call it a day. So I'm going to have 8x to the 7th minus 10x to the 4th minus sine of x minus e to the x. My second derivative here is going to be 56x to the 6th minus 40x to the 3rd minus cosine of x minus e to the x. My third derivative is going to be 6 times 56, x to the 5th minus 120x squared. And then the derivative of cosine is negative sine, so this becomes a positive sine, minus e to the x. And then the fourth derivative is going to be 6 times 5 times 56, x to the 4th minus 240x plus cosine of x minus e to the x. Of course, I didn't simplify that, but you could probably simplify this if you have your calculator and see what that is right there. All right, last couple of problems. Let's say that you're given a table, something like this, where f and g are differentiable functions. And for number 15, you want to find the derivative of f of x times g of x at x is equal to 3. So using our product rule, we're going to say first times the derivative of the second plus second times the derivative of the first. And that's going to be my derivative. And then since I want to find the derivative at 3, I'm just going to plug in 3 and see where that takes me. If I do that, f of 3 is 7. G prime of 3 is negative 1. G of 3 is negative 4. And then f prime of 3 is 3 halves. If you simplify that, you're going to get 7 and then minus 6, which is negative 13. Or, of course, you could just leave it like that. Same thing with 16 through 19. Lots of fun. Love tables. Love product and quotient rule. All right, in the next video, we are going to be talking about chain, and we are going to talk about implicit. Lots of fun.